Well, welcome everybody who is here. We are ready to do, I think this is our 10th or 11th Postgres 101, which is pretty awesome. Yeah, we're going to get going today. This one is about Postgres functions and procedures. And again, Grant and I have been doing these kind of from the SQL Server, perspective, things that we were used to and how they work differently in Postgres. So we're going to get rolling through these. My name is Ryan Booz, and I'm an advocate with Grant here at Redgate. And I joined 2 years ago, just almost exactly 2 years ago. I think I'm over by a week, to help with the Postgres story at Redgate. I've been a Redgate customer for years and love the tooling. And when I saw that Redgate was taking on Postgres and other databases, that just really excited me. So it's been a great team to be a part of and lots of really exciting stuff happening. So feel free to reach out to me. I love after these sessions if people connect and ask more questions. And both of us, I know, are just happy to connect and help.
And my name is Grant Fritchey, and I work for Redgate as an advocate as well. And 13 years in, I love it. I love my job. I love the organization. And I'm 2 years, well, gosh, no, I'm coming up on three years on learning Postgres. I'm loving the technology there. It's a lot of fun, and presenting on it is fantastic. Great community. And same with Ryan. This is my contact information. You have questions after today, please reach out. I live for questions. Heck, they drive my blog. I've got a list of questions in my book I've got to work on for blog posts to answer. Stuff like this is huge. So please do take advantage of the contact that you see there. Cool.
All right. So I think you keep moving here.
Yep. So Postgres 101, we've been doing a whole bunch of, like you said, this is 10 or 11. Most of them have been new. I've only been involved in a couple, it's an ongoing series. If you are trying to learn Postgres yourself, this is set up for you, right? This is very much a 101 level stuff. Heck, I go back and rewatch some of these sometimes. So I'm using them as part of my Postgres learning. So hopefully that you will find them useful for your Postgres learning as well. Let's go on to the next one. So yes, indeed, the session is going to be recorded, and there is a Q&A box that you can write your session questions into. You can start writing questions now, and we will try to answer them as we can. But please don't hesitate to ask us questions, and we're ready to go. So, the goals here are pretty simple. What we're doing is we want to talk about Postgres, right? I mean, but mainly today we're talking about functions and procedures and the differences between them and other stuff that you might be used to, so that you can see what's going on. And hopefully we will hit the information that you need to understand the differences between what a function is, what a procedure is, where you use a function versus where you use a procedure, and then of course how to use those once you've created them. It's not hard, but it is a little different, so it's worth knowing. And with that, it's I believe Ryan's turn to keep going.
Yeah, so Grant, you and I have talked a little bit about this. One of the things that's interesting about writing functions and procedures within Postgres is that there's a plethora of languages that you can use, right? In SQL Server, we can use more than T-SQL, but we get into CLR stuff and having to make sure that we have permissions and privileges to install those things and make all that work together. And that's not always easy across, especially if you're supporting client, installations, things like that. So the one unique thing, and I want to call this out first before we talk about the languages that are possible. The one unique thing here is that some of the languages are what Postgres considers trusted, and some of them are untrusted. And what that means is this: trusted language is the wrapper that ultimately executes the code inside of the Postgres shell against the database and so forth, has essentially prevented or disabled some functions that would allow people, the code itself, to access like database internals, even OS level kinds of things like the disk, the file system, getting awareness of what the actual OS is that's running. And so those things have been disabled in a way kind of to sandbox and protect the actual database server that's running. And so when you use a trusted language, you can rest assured that even a non-privileged user, someone that doesn't have super user access that runs these functions or these procedures can't do something, quite honestly, nefarious, even if it wasn't intended to be nefarious. They can't get outside of that box. And so not all, in fact, only a few languages to this day are still actually trusted because, well, I shouldn't say that. More and more are. I've actually been impressed how far people have gotten with this. But you just have to be aware of it and just know, depending on what you're trying to do, you might have to just take some precautions internally to make sure that nothing bad can happen. And so obviously the antithesis of that is that there are also untrusted languages. And that simply means that there's a wrapper that will execute the code, right? You have, let's say Python, for instance, you'll see in a second, is currently untrusted. That means that as long as you have the Python shell executable available on the server, Postgres can go ahead and execute Python and do lots of really cool things. But there's no current safeguard in the connection between the Python and the database server that prevents potentially like accessing a discom file or something of that nature. And so you just have to be aware of that. And there's lots of guidance on how to do those things and obviously the kinds of operations you should avoid. Now, generally, only super users can create functions with an untrusted language. That's not 100% true, but generally they're set up in that way so that only super users can do it because you could do some bad things. So they want to make sure that you have that level of access. We don't like bad things. So what are the languages? Now there are more than this. These first four are actually available in the core version of Postgres. They're actually they're shipped with and available as part of the core application. But like everything else, they have to be enabled in some way. So by default, PL/PG/SQL is, I've said that, both Grant and I've said this in previous sessions and places, when we talk about Postgres, T-SQL is, SQL Server's procedural SQL language. And PL/PG/SQL is Postgres's default procedural SQL language. And so it has other things that you can do, loops and so forth. Python's available, it's untrusted, and then TCL and Perl are available as both. You can install them as trusted or untrusted. Now, again, I don't know how many people Grant, that are doing TCL. I haven't touched TCL like since 1998 when I played with something to do a GUI in some way. Last time anybody?
I don't know if I've ever touched TCL. So yeah, I wouldn't
I tried it
recommend
once. And then Perl, I
You
was
were
kind of laughed
young.
at Perl when I was a wee lad. The Perl always surprised me because I did use a lot of Perl early in my sysadmin days. Like Perl was the language for doing all kinds of that stuff, and obviously it was actually one of the first widely used web CGI languages to do server work. But I don't know a lot of people doing Perl these days. Turns out that it is still actively developed. They actually just released a new version this year, I found out. But because the shell, the interaction in Postgres, the person that developed it originally a long time ago, did that sandboxing. So it's one of the few comes with Postgres trusted languages, and it has a pretty wide. There's lots of plugins you can use with Perl. There's actually a lot you can do with it, but I thought that was funny. I haven't thought about Perl in a long time. And then you can install other languages by extension. And as again, we did an extension talk, I think last year. You can go watch it. The reality is extensions there are many of them, hundreds, actually technically thousands already. If you're in a hosted environment, only maybe 75 to 100, maybe a little bit less, are actually approved in most hosting environments. So AWS or Azure or Google, the cloud computing stuff, whatever they're doing with Postgres. They have to approve because the extensions have to be installed on the OS to be available to Postgres. And so some of these will not be available if you are hosted in an environment like that. Now, if you self-host, you can install these extensions on your computer and install these languages. Rust is getting huge, a lot of airtime in the Postgres community and just generally. And so Rust came out last year as a supported language, both trusted and untrusted, and can do some really cool things. And so that might really, People use that more and more. Java obviously is often available because it's used so much. And actually, the gentleman who helps with the JDBC in Postgres, actually, I just learned this from him a little bit ago, Dave Kramer. He actually maintains the PLR extension. I guess he used to do R, and I was like, oh, that's kind of cool, Dave. I didn't know you did that. So lots of stuff, even JavaScript, right? You can do the V8 processor for JavaScript, which is actually trusted. So anyway, that just to know that ahead of time, that really, if these extensions are available, you can write functions using any of these and do all kinds of cool things, right? You can do data science with Python if it's available and you take the precautions. Pretty cool. All right, so let's talk about functions.
Functions, I've heard of them. So functions, pretty straightforward. Functions are about returning data. The whole, can you use them for doing other things? 100%. You sure can. But the general reason that functions exist is to return data. They are for running, storing and keeping queries and running a query. And so they operate more or less the same way as an Oracle function. Oracle functions are literally the same thing, or what we call stored procedures in SQL Server are the equivalent of functions in Postgres. Not exactly equivalent because of all kinds of weirdness and fun. But if you're looking like when I first started looking for, I want to store a query in the database, I started looking at procedures in Postgres, and I had all kinds of problems because they don't work the way I expected them to. So now so you won't have to hit the problem that I hit. You're ready. You're going to go after functions instead of going after procedures. All right. So functions, the basics are pretty straightforward. There's not really any real trick to it. You're going to run a create function command, right? It's really no big deal. You can run create or replace, certainly, but there are some limitations in the way the create function works. And the big limitation is in the parameters. Once you have created a function with a set of parameters, if you go to change those parameters, you can't simply replace the existing function because it's a new function now with new parameters. So that's one thing to keep in mind, that if you do modify parameters, you will need to drop and recreate. No big deal, no problem, but just a bit of knowledge. So what else do you have to provide? You have to give the function a name. Ooh, that's tricky. Okay, moving on. You do have to define the result set or the value or the record or tuple that you're returning. Now you can return a full-on result set, bunch of rows, one row, however you want to define it. You can define it as a tuple, as a single result row or record, or you can define it as a value. So you can have these things just return a single value. So it really is up to you to define how it is that you want this function to return the data that you want it to return. Next up, you have to create a code block. Oh my gosh. Well, I mean, again, not a shock, shouldn't be. You have to really, if you're running a select statement, you have to create the select statement, right? And it goes from there. And then finally, going back to those languages that Ryan just went over, we have to define the language that we use. So these are the basics for running the create function. I mean, and it's nothing you should be shocked by, nothing that should be surprised by. Create function, give it a name, define the result set, create the code block, whatever it might be, and then define the language used. And this is the bare minimums. Now you don't have to provide parameters. That's something you can decide whether or not you want to do. You can use variables inside. You can have multi-statements. You can have all kinds of use cases and all the rest of the stuff. The code block is up to you to figure out. But the straightforward stuff that you have to give it are really simple. Now, code blocks, you can just do, a begin and end for a code block. That's all you have to do. But most people writing Postgres also use these things called dollar quotes, dollar quoting. And so it's double dollars at the beginning and double dollars at the end. And the main reason you do this, and there's a number of other reasons, but the main reason you do this is because it ensures that when you're dealing with strings inside, You can use single quotes around the strings instead of double single quotes. Remember, that's not double quotes, it's double single quotes. Um, that is a pain. It is something we've suffered from sometimes in SQL Server, and I hate it. When you start getting into stuff where you're doing that, it's always painful. So with the dollar sign quoting, you can avoid that. Now, the other thing we can define is parameters, and defining parameters is really straightforward. Again, it's especially if you've already got knowledge of Oracle, knowledge of SQL Server, it's the same concept. You're going to give it a name and a data type. Define whether or not it's nullable, and then off you go. You've got everything you need to define your parameters. Now, parameters again are separate from variables, and this is a common misnaming across most of the database platforms I've worked with. I've seen lots of people refer to variables inside of their stored procedures in SQL Server when they mean parameters. Now, the parameters are defined at the function. I almost said procedure. Defined at the function level, and variables are defined inside of the function itself. And so variables are once you're working with them, they're a lot like parameters. It's all the same. But the one thing you do need to know is, unlike a lot of other things, we do have to worry about case sensitivity inside of Postgres. That is definitely something that's going to come up. Now, the example we have here is a really simple one. I'm creating a function against this blue box movie database that Ryan created, and we've been using for our book and other stuff. Oh gosh, I said book.
Did you say
Anyway,
book?
I said book. Uh-oh. Anyway,
Shh.
nobody's supposed to know about that. Please, please, everyone who's listening, don't tweet that. That would be bad. I'm
Yeah,
kidding.
don't
You
talk
can
about the
tweet it all
book
you
that
want.
you're going to see at the second to last slide.
Yeah.
I'm sorry, you were saying something about the function example?
Anyway, moving on. Functions.
Yeah.
So I've heard of functions. So it's basically really straightforward. You see, I'm creating a function, I'm giving it a name. Now, this function, I'm not giving a parameter list. So I've got the open and close params. I'm returning a table. So I've defined my result set. That table consists of the genre ID and an integer, and genre name, which is text. And then actually same as SQL Server. Now I've got my dollar quotes so that we're working within those. And then I've got my begin and end statement to provide my code block. Once I've got the code block, it's return a query, and the query is select these values from this table, and then the language is PLPG SQL. So from a functional standpoint, it's really straightforward. There's really nothing to it. This is how you write a function, and ta-da, it's easy, right? Can you make it complicated? Yes. Will you make it complicated? Oh, yes, guaranteed. But the core, the basics are really straightforward. So you can see it here. It's not difficult. There's just a little bit of syntactic sugar that you have to apply around the edges, and then everything just works.
Yeah.
Now, how do
Yeah, we're
you?
going to get to the next one.
Oh, sorry.
Sorry. No, no, you're
Yeah, I
right.
was
I
going to say
thought there was something else, but that's coming. Aha.
I got two more.
Yeah.
Um, so the next thing is, what could Grant possibly write a book about? I'm sorry, I'm looking at the questions.
I
Um,
know. I see that.
so now the next thing is, so now we've created a function. Well, how do we use functions? Well, interestingly enough, in Postgres, and this is a little different from some of the other tools that you might use, they are treated like a table. You're going to write a select statement to pull information out of a function. Now, granted, if you're a SQL Server person, you're going, well, yeah, I use select statements on functions. But remember, functions are procedures. And so a function inside of Postgres is treated like a table. And so we select from the function. But that also means that we can do select star from the function. We can do select and define a limited column list. We don't have to just take the stuff it gives us. We can define and pick and choose which of the columns from that function that we use. And it means we can use it in a join. So you could join a function to a table, or even a function to another function. And yeah, I hear some SQL Server people screaming in horror right now, and I join you in that. because it does scare the heck out of me that we're going to start joining functions to functions. However, it works, and PostgreSQL is built around this concept of object, right? It is an object relational database. It is not simply a relational database. And because of that, we're treating these things like tables, and we can then treat them fully like tables within our SQL. So if we look at an example of that, there it is. Cool. I'm just scrolling down so I can see what's going on. It's really straightforward. Select, I'm giving it a couple of names from my function list. And yes, I aliased my function list. I alias everything. I can't help it. I'm so used to doing it that way. I just can't help it. But anyway, I've selected a couple of columns from the function as GL, and really once you're in there, you're treating it a lot like a table, and there's really no major differences in terms of how you consume the data out of that function. So I mean, that's one of the beautiful things about it. But Ryan's got a few more wrinkles that he wants to talk about.
Yeah, so a couple things to realize that Postgres can do a little bit differently is that, again, this has been, as Grant said, this has been designed around this idea that the planner in Postgres is built to understand all these possibilities, right? So again, we kind of, get a little bit anxious about using functions too much at times, coming from the SQL Server side of things, but recognize that the actual planner has been developed to be able to handle these things. And so you can actually give some more feedback to the planner when you create or you update or modify your function in honestly your procedure as well. So with the function at least, we can identify the cost in the rows to influence the way the planner works. So by default, if you don't, a set returning function will assume 100 rows. That might sound kind of familiar to what we're used to in SQL Server, at least in the older days. I'm sorry, cost. So you can set the cost to 100. By default, it's 100. You can set the cost higher. And so a higher cost might force a different kind of execution rather than a seek scan. So a table scan some sort, maybe it would force it more towards an index or some kind of different join pattern. Instead of a loop join, maybe it will try and figure out if there is a merge possibility and take that instead. And so you can actually set that on your function to kind of influence what happens there. And then you can also determine the amount of rows that the planner thinks are going to come out of that function, again, to take into account how the plan is created. And so by default, it's 1,000 if you don't specify it. But then again, you can have more or less. And then the other two, there are a few others, but the other two I wanted to mention here, one is the set command within a stored procedure and function. So there are lots of runtime session properties, parameters that you can set with the set command. The one that I see most often, and it's actually getting a lot more airtime recently, is search path. So in Postgres, when you have schemas, by default, when I connect to a database, the default search path, the schemas that when I say select star from table, it's going to search for that table in the schemas that are part of my search path. Well, if I have multiple schemas and I don't qualify that table, I'll likely get a table not found because it doesn't know to go look in, maybe in this case, the blue box schema. And so from a security perspective, there's a whole lot more in this, but the new kind of recommendation within the community is that if you can fully qualify everything with inside of a function, because if you don't, someone nefarious could install the function that you're planning to use inside of your function in like the public schema and replace it. And so you end up, if you are not specific, it calls that one rather than the one that you intended. And so if you can't fully qualify, the other possibility is just to say, look, I'm going to set the search path for this function. Don't even look at public. Everything inside of this function, the queries reference things in this other schema, and that just kind of negates everything. So you'll see that often in examples more and more, I think. And then one of the other things that's kind of cool is you can basically tell Postgres, is this function, can it be used in a parallel query set? Right, so by default, it assumes that all functions are parallel unsafe. As soon as you reference a function, it will become a serial execution plan. But if you say, hey, this function is parallel safe, then it will at least open up the possibility that you could have multiple processes running to, query the data using this function. So obviously, if you're not modifying, if the function simply, processes something that can be merged together in some way because of ordering, great. It's a parallel safe function, and you could do something with that. Again, it's a tweak that you can make to possibly increase performance depending on what you're trying to do. So there are others. These are the couple that I have seen and more and more people talk about, particularly as data sets grow. And so this is what two of those look like. So again, with functions, since it returns a set or can return a set, we have cost and row possibilities to influence how the planner sees it. So in this case, I've said, hey, this function, assume a cost of 10,000, which might push it more towards like an index usage or bitmap index usage in some way, rather than, hey, this doesn't cost that much, and so we're just going to scan all the rows that come out of this. And then I say, hey, this is going to return 100,000 rows, which will influence in some way what happens. So kind of cool. And then the other one, like I said, that you'll see often is search path. So in this case, I meant to point it out back here, you'll notice that I have public from film genre at the third line from the bottom there. And so I'm qualifying the public schema. Well, if this was in a different schema, let's say the blue box schema, I can say, hey, set the search path of this function to first start with blue box, then look at public. And if film genre is in blue box, it will find it there first. And so you can specifically determine not just where tables are at, but all of the functions you're calling, where they're at. And I think, yeah, so I didn't qualify this one, and now I'm saying blue box, and it will find it there. All right. Woo.
So I'm muted. Okay, so that's functions. Functions retrieve data. And what are procedures? Procedures, again, similar to Oracle procedures or similar to SQL Server functions, procedures do something. They perform an action. So it's a little different, and obviously the results are going to be a little bit different. Let's go ahead and talk about them in a little bit more detail. So the concept is the same. Create procedure command. Same rules apply. Create a procedure, create or alter a procedure, those all work. But if you have parameters for that procedure, and yes, you can have parameters with a procedure, if you change the parameters, you will have to drop and recreate because that means it's a new procedure. So it is a different object within the database and you will have to recreate it. Cool. Provide it a name, give it a code block, define the language used. All structurally the same. So now in this case, for this procedure example, what I've got here is, again, create or replace. Like I said, procedure, gave it a name, provided a parameter value, genre, text, as, again, begin and end block code, dollar quotes again around the code, and then insert into blue box the name, the values is genre name. Define the language, and off we go. I mean, it's really straightforward. But let's take a look at the in-out example, because you can return values from a procedure. And so what we've got here is a slightly different procedure. Again, give it a name, define the values, but now I've used the in-out description on one of the parameters. So the genre count value can be retrieved from the procedure. Now the query itself is, select star into genre count from film where the genre matches a particular genre ID. So it's nothing complex, nothing crazy, but it's basically just a way to give me a count of all of the number of films that are in a particular genre. So simple, nothing crazy, but it does allow you to return a value from a procedure as well as perform actions. Now, using procedures are a little different. They are not treated like tables. Instead of a select, to use a procedure, you have to call the procedure. And then for the in-out parameters, you will have to define those so that you're using them appropriately. Let's go ahead and bring up the example. Why not? So to call my new genre procedure, it's really simple. Call new genre anime. That will insert a value into the genre table, and I will now have the anime procedure. And I can't believe he left anime out of his example database, so I had to add it in there. But I'm teasing.
So
It's
the
all cool.
genres came out of the movie database I'm using, but you know what? We're going to go change that. We'll add it into the movie database.
So anyway, as a bit of an anime fan, I had to add the anime genre in there, so we put some movies in as well. But now, fine, that's the one. Now, what about if I want to use the in out? Well, I'm going to put this inside of a code block. So I've got a do and end. I've got my dollar quotes, and now I'm going to declare a value, genre counts. And within my begin and end, I'm going to call genre count. I'm going to say wherever the genre ID is greater than or equal to 27, or I'm sorry, that's the input. That's not greater than equal to.
Yeah,
That was my SQL brain. Pay no attention to
I
that.
hear you.
That's how you assign it. So I'm assigning the genre ID to 27, and then I'm assigning the genre count to my variable genre counts. With that, I can then that's going to run the procedure. And then when I do the raise notice, it's going to say the number of films in this genre are, and it's going to return from the genre counts value. So using these things is really straightforward. There's nothing shocking or strange. I mean, you can put it right to work. Now, where are we on the slide deck? We're up on 27. Oh, it's you.
So the various things that we can do within procedural language and PLPG SQL, since that's what you'll see most frequently, is everything else you would expect. So we can actually define different blocks, different begin and end blocks itself. We can do variables, we can do looping, error handling, case statements. We can call other functions, we can call other procedures. There are, a lot of it is what you'd expect. Some of the nuance of how to actually, identify some of those transactions, some of those variables, and some of those properties will be a little bit different depending on maybe how old the procedure is. If you're looking at examples, some of the ways that it's done has changed over time, but you might see like an equal sign colon, which is a way to assign a value to a variable, but you don't actually have to do that all the time. And so some of those things, as you learn, as you see, it won't be that hard to differentiate from what you already know. It's mostly that back and forth of procedures are more like functions and functions are more like procedures from the SQL Server side of things, kind of reverse. The one thing I was going to mention, as Grant's examples and our examples there were, just good, quick, easy examples of PLPG SQL. I realized I forgot to put in that first slide that all of these things you can write a procedure and a function just in plain SQL. You can't do any of the procedural stuff, but that is very possible, right?
Forgot that too.
Oh, as you're
I knew
talking, I'm
that,
like,
but
oh,
I just
we
spaced it when I
didn't.
was.
Yeah,
Yeah, yeah.
that was easy. So, and I thought it was interesting, Grant. You didn't say this, but I'm going to go back to the slide really quickly. We talked about this in one of the previous PG 101s. What Grant is showing here is this do loop is technically called an anonymous function, right? So there's no definition to it, but once you put that do dollar sign, Postgres is going to interpret this as PLPG SQL unless you give it another language. That's how you do this stuff. You can't just run it in free space in the middle of a script. You have to kind of
Right.
differentiate that zone. All right, last thing I wanted to point out is that this is unique to Postgres, again, compared to SQL Server. And I actually use this a lot over the last 6 or 7 years of using Postgres. A lot of the data that I've been processing in applications and helping customers ends up being millions of rows of data. And often you're doing data dumps, you're importing CSV files and processing stuff and a staging kind of workflow, and you manipulate the data, insert it somewhere else. Well, in SQL Server, right, you can have you can identify new begin transactions within a store procedure. But even to a save point, if the containing procedure totally bombs and it can't get back, all of the stuff internally is rolled back. In Postgres, when you actually say begin and commit inside of that procedure, maybe you're doing a loop and you're processing 1,000 rows at a time, that commit is done. It has its own transaction ID, it's committed. And this is a really useful way when you are processing millions of rows of data and you just want to know how far along I've gotten so that if something does fail, you don't have to start all the way over again. You can, oh, I processed 800,000 of a million. I can start a little bit later, and just the one that was going is roll back. It's just really
Cool.
helpful. I've used it a ton. There are nuances, and the community itself is not fully bought in to some of the problems that can happen in sub-transaction. But in that example, I found it really, really helpful in stored procedures to do that for that kind of data processing. So the
And I should say that
summary.
submarine was so much nicer than the Victor you had earlier. So
Yeah, sorry. I looked up sub transaction. I thought, oh, I'll put a picture of submarine. And Grant said, that is not a US submarine. I was like, I'm sorry. He knows probably every military grade plane, submarine, warship. He's a history buff. I just happen to be correct. So here's the quick functions are for returning data and all the nuances of what happens with that. There's so many cool things you can end up doing with it. But functions for returning data, whether it's a scalar value or a set, or a table that you define in some way. And procedures are generally for performing actions of some sort. It can be as simple as what Grant just showed, inserting data, or for doing more looping kind of workflow kind of things. That's usually a good use case for procedures. And you can spit out those notices as a way of getting feedback, or raise errors into the log if you need to keep track of what's going on there. So, all right. So our goals, what were they, and how did we hit, Grant?
hey, we hit them. We nailed it. I'm sorry. No, I'm totally kidding.
Awesome.
Hopefully we did cover the stuff that we said we were going to cover. The difference between procedures, and functions, which do you use when, and then how do you create them and edit them? Now we didn't show an example of edit, but it's the same as creating. I mean, it's really create or replace and put some code in and off you go. And hopefully we showed you some of how to use them. So yeah, I think we hit the stuff that we said we were going to hit pretty well.
Yeah.
Hey, what's going on in the future?
Well, we just were talking about getting back from Athens from the Postgres conference, and man, we get a couple days, and then we have to head out to Seattle. What's happening in Seattle next week, Grant?
There's this little event, little tiny data event. It's only, a couple of thousand of my closest friends are
That's
all getting
it.
together in Seattle at the Past Data Community Summit. And the fun thing is that we're doing a whole bunch of Postgres at the Past Data Community Summit
We are.
because there's some other stuff going on. In fact, what else is going on at the Past Data Community Summit there, Ryan?
Well, we are working with another open source nonprofit to actually host a separate, but in the same building, Postgres conference for 2 days, for Wednesday and Thursday. We are working with the Postgres conference. That's actually the name, Postgres conference, and they are hosting a 2-day, 3-track event. And a few of us are going to be helping out with that as well. So it's a way to start to intermingle, these two different communities. We know lots of the SQL Server data platform community is starting to get interested or needs to understand better Postgres. And there's a lot that you and I talk about, and so many in the SQL family talk about the community that we have enjoyed for years and years. And, introducing and just allowing some of that cross-pollination, as it were. So we're really excited about that. So whether you're
And
SQL
by the way,
Server, yeah.
oh no, sorry, go ahead. Well, I mean, and by the way, you and I have a pre-con.
Oh, well, yeah, the first thing. So we're doing a pre-con all day, which is kind of related to a thing, Grant. And so if you haven't
Let's
registered
mention
yet,
the
there's
thing.
still a possibility, and it's going to follow this thing that's called a book. Yeah, we're going to, Grant and I wrote a thing. And so this will be released in preview at Past Data Summit. I actually got the first preview copy, which I forgot to take out of my bag. It's over here, but we have one physical copy of this. It's been a lot. We took it to Athens this week, and honestly, it was exciting to see how people reacted to and really excited about the content of the book. So I'm really excited to see this come out. If you are there, Grant and I will be doing a book signing, I think on Thursday at some point. We're actually going to be able to give away maybe 100, a little bit more than that, of these books. And we're just excited to connect with people and do that. But even if you're not there, I think we have a surprise.
We do have a surprise.
I feel like, Grant, we tend to be a generous company, and we tend to really want to help the community. So I just feel like, let's give away some books.
Fine. We'll give away a
All right, we'll give
couple.
away some books. So if you register for this webinar, which you're watching, and so you did register for this webinar beforehand, We picked 3 random winners, and we'll be in contact with you to talk about how to get a copy of this book. So what we're giving away at Pass is a preview copy. There's some things we have to edit and fix. There's a chapter we didn't have time to finish. And so, but we wanted to have something at Summit. And so we're actually finishing that chapter up. And probably early February, first week of February, it will be officially released, and we'll make sure you get a copy. So the 3 winners today are Annabelle Morales, Anders Mathiasen, and Edmar Francisco. So you will be contacted if you're watching this. The team will reach out to you. If you watch it later, they'll get in contact with you. So congratulations. We're excited to start to share this content with everyone. And we have a little bit of time for some questions.
Yeah, we've got questions. First one.
All right, let's go.
Will a function return the result sets to the screen, or do you have to capture the output with an apply? And with an app, sorry, app. Reading is fundamental. Good news, it returns to the screen. If you're running it through the command line, you will see a result set come back. If you're running it through one of the tools, dbeaver or whatever, you will see a result set come back. You will see the information come back to your screen from a function. If you're running a procedure, you will not see it unless you do some of the stuff like I did with that in-out parameter, so that you can then some way to display that in-out the parameter value. So you would only get it that way. But can you get them back to the screen? Absolutely, you can.
Yeah, and we'll talk about that. We talked about that in the book a little bit, and if you come to the pre-con, we'll talk about that.
Yeah.
Stored procedures, that is even the anonymous function. So a created function, that's why we often say in Postgres, if you're going to redo something more than once, create a function for it. If you do that anonymous code block, that's kind of in between. It's not a complete function and it's not a stored procedure, but the output side of thing kind of works like a procedure. So with a procedure, if you want data out, you have to insert it into a table, or you have to do some other work creatively, like the raise statements, to actually get feedback from the procedure.
Right. Well,
so
now, yeah, go ahead.
Go
you
ahead.
take that one.
So
Number 4.
PLPG functions are always like T-SQL table value functions, no scalar functions in PLPG SQL. So it's that nuance, right? They actually, you can return a scalar value. You can say returns int, right? So it can be a scalar, but there's not the differentiation necessarily from the query planner underneath. Now, obviously, if it's returning a value, it will cost it 1 row and some of those things. But there's not quite that full distinction. We don't talk about table valued functions. We actually call them set returning functions, which is essentially the same thing. And it does allow you to do some other stuff when it comes to applies and how you do cross joins and some other stuff. Well, we don't have applies, but similar, we have cross joins and so forth. So there are, yes, it's essentially one thing. The vast majority of the time, they're used to return a set of some sort, however you define that.
Right. And so then the next question is, are functions always created as a table? So 1, no, but 2, yes. In that, to retrieve the information from a function, you run a select. So on that level, it is sort of treated like a function. But I mean, as Ryan just defined, you can certainly make them into a scalar, so it returns a single value.
Yeah, so you can have a function as a column, right? Like you can call a function to do something. We use them all the time. We have uppercase, or we have, unnest, or whatever those things are, you can do from a column perspective. But that function is still returning something. It's returning either a scalar value, it's returning a set of something that will become multiple rows in a result set, whatever that might be.
Right.
Can you use functions to calculate something, for example?
No, that's still the same question. You're number
same
6.
question. Okay, we're number 6.
Yeah.
How do you know if a function is parallel safe? What does that mean? I'm not clear on that. So it's a good question. I would say most of the time, until you understand the Postgres query planner and what your function is doing more, it probably isn't worth knowing. I've just seen more discussion of it lately as data sets get bigger, and there's Postgres has been focusing more on how to efficiently do parallel querying. which we do support, but just how to do it differently. So the function cannot, so basically it has to be a stable function. It can't, let's say you're doing an operation where you're reading rows. Well, both functions shouldn't be returning the same sets of rows. That's not parallel safe. But if the functions are calculating values dependent on the rows that are coming in, or it's what we call a oh my goodness, how did I just forget this? Not applies, but wow, brain freeze. Our equivalent of apply, which is going to lateral join. Woo,
Oh
woo.
yeah, lateral join.
The
I'm like
lateral,
trying to think of it too. Go
yeah, the
ahead.
lateral you can basically take input from something on the left, and so if you do that, again, as long as it's maybe calculating values that are not going to be impacted by two processes running at the same time across different rows, it's technically parallel safe then. It's advanced. It's just one of the many things. I just know that more and more people are, we're talking about it because there's so much more parallelism going on.
Number 8's yours. Oh no, sorry, number 7's yours.
Number 7, one disappointment in Postgres is the lack of user-defined table types. Do you have any tips and tricks to make up for the different SQL Server? There is no such thing. You're right. So you cannot define a temporary table as variable. Honestly, the only real solution you have is to create a temporary table and insert data into it and use that further down the line. Pros and cons, who knows? If it someday really becomes a need, then someone can create a patch for it. You're welcome to email the list and make a pitch, trying to get people to come on board.
All right, so the next one is if you can join functions to functions, does this hit tempdb pretty hard? Hey, no.
Why
And
not,
you know
Grant?
what? Because there's no tempdb. So,
What?
yes, no tempdb. No, so it will not hit tempdb very hard. If so, do you need to vacuum lots? Again, no, not really. Functions just don't work that way, and it's just not the same. It's just internally and functionally not the same kind of behaviors as what we think of when we say SQL Server. But the one thing I will say is obviously joining two functions could smash memory, could cause I/O issues, definitely could, there's no magic, right? Nothing's free. Tan Staffel always applies, and for those who don't know what it is, look it up. But Tan Staffel always applies, and so there's no getting away from that stuff. Now, it's not going to hit tempdb, but it still could hit your memory. You still could see issues with I/O and other things. I mean, so there's no magic to it. You can join function to function, but that can cause you problems.
Yeah.
Cool.
Every operation, like a join, is going to take the possibility of what we call work command. We've talked about that in previous PG 101s. And so, yes, if you're processing lots of rows down the pipe, one of those functions very likely could build a disk. We call it an external event of some sort. And so then you might have to determine that will be an external, not tempdb like we think about it. It's a temporary space that's just kind of transactional in that way, and then it's dropped. All right, a couple more because we got a little bit of time. So number 9 is in SQL Server you can schema bind a function but not a store procedure. How's Postgres handle this? So you can man, my brain is gonna stop here because I feel like yesterday when I was looking at this, there's something new that I found. However, when you execute, so generally when you execute the creation of either of these, it will determine whether or not the schema that you're referencing is consistent and is possible, including functions or store procedures that you reference, outbound parameters, so forth like that. There are a couple of ways that you can identify dependencies. A little bit more to get into than we probably have time here, but it's not quite this. You can't specifically say this function schema bound, therefore anything that references this function is always going to check everything internally in this function to make sure. Now, dependency wise, most of that's tracked, and you likely won't be able to drop a table, for instance, if a function is referencing it. There's some internal checks, but not quite in the same way that you would do at SQL Server.
Sure. Hey, the next several questions are yours.
There we go. Create Postgres functions so it would. Oh, so it would have some synergy to index views in SQL Server. So Postgres has what we call materialized views, which are analogous to index views, and we have functions already in place that will refresh that view. It's not exactly the same, and yes, many people will do materialized views with some kind of triggers that would determine when and how those views are updated. Or you can do something with triggers that would actually create your roll-up table and only modify specific rows as data is maintained. So it's just a different concept, same concept, different, excuse me, different language. You can look at the nuance and reach out. We can talk more about materialized views and some other things are being done internally within Postgres and some commits that might impact that over the next couple of versions. Function procedures being defined within a designated database, not public schema, are permissions initially inherited, and or how do you share permissions with other users? Okay, so I'm mostly going to say this. We have a PG 101 session on roles and security. We'll try and include that, hint to the team that's helping with this. We're trying to include that in the email or follow-up email. Essentially, here's the deal. You can decide with functions and procedures, you can set a security definer. And that says, hey, when someone executes this, are they executing it as me, the owner, which is the default, or are they executing it as them and the permissions they have? And so that has evolved over time. So you can set that. But remember then, every object that's created in Postgres by default is owned by the role that creates it. And they are the super user of the role. So you cannot give permission to any other role to modify your function or store procedure. Only your role can do it. Now, if it's a group role, and again, that's in that talk, other roles can be a part of the group role and they then can modify the function. But only the owner of an object across the board can modify that object. That's tables, functions, store procedures, views, all those things. And how do you deal with? You cannot log an error information to a log table because it will be rolled back. I'm not sure I fully get that.
Yeah, I don't get that one, so I didn't want to try. I mean, I can answer the next one, but I've got no idea on that one.
So when you do a raise
Maybe
error,
just send us
that's
an
how we
email with
log.
more detail.
Yeah, you reach out. When you do raise an
Yeah,
error in a
please.
function store procedure, it will go to the log. And that's not going to be rolled back. That's sent to the log, even if the rollback then does trigger, which will also be logged, right? There's a rollback of some sort.
Right.
But maybe I'm just not understanding that, so please feel free to reach out.
Right. So how do you design a store procedure or function in an IDE without creating it? Specifically, we need variables or variables that will be parameters. That's inside of a do loop. That's how I do it. It's the same concept. You're gonna create that do command, put the dollar signs in, create create variables as parameters, or parameters as variables, however you want to think about it. Write the query that you want to write. And then test it all out so that you can validate that functionally it's doing what you want it to do. And then when you're
Exactly.
ready, then you can create a procedure out of that. That's how I would do it. I mean, so straight up. I mean,
Yep. Yeah, I would do the same thing. As you get each piece, then you create the procedure. You will get feedback. Postgres is pretty good about telling you what function and where, and give you a pretty
oh yeah,
decent hint of what's going on. So it's easy to work these things through as you develop them.
yeah. That's how I would do it. I mean, I've done it almost exactly that way inside of dbeaver. So
Yeah.
it'll work that way. Cool. Well, it looks
All
like that's the
right.
last of our questions.
Man, we got a lot of great questions. Thank you so much for being
Yeah.
here and for asking good stuff.
And that's it, right? We're wrapping up.
I
Well,
think
thanks for
so.
your time.
Yeah. Hey, Grant, where are you going to be next week?
I'm going to be at Past Data Community Summit.
Oh, I'm going to be there too. I'll see you there.
Excellent. I
Hopefully
will
we'll
see
see you
you
there
there.
too.
Yeah, we're seeing a few people.
Cheers, everybody.